secretary there?
Yeah, well, we had 20 odd people in the department.
Oh.
So, yeah.
T184.
Yeah, she called it a T184. All right, so on your calculator, I want you to have in y1, y equals e to the x, and y2, the derivative of e to the x.
You want radian mode, right?
It doesn't matter. This is not a trig function.
Oh wow, it's the exact same.
How do you know that?
Because I graphed. What? I graphed it.
So how do you, but if it's exactly the same, how do you know?
Because they overlap.
Oh, because yours is a color one, isn't it? So did the color change?
Yeah.
Nice.
As it goes.
Nice.
Python so it does it faster, so I can do my graphs faster. And
This is what I'm looking for.
I did in
Oh.
Yeah, it's fun.
I think I graphed. Oh.
Did you use,
I did the inverse.
no, the derivative, not the inverse?
Yeah.
Because you do the inverse, you should get natural log.
Probably.
So just as a reminder, you can type e to the x inside of the derivative, or you can just go, oh, that thing that's in y1, use it.
How do I do that?
Alpha the Y one before. Alpha.
Oh, okay. Hey.
I wonder if that works whenever like do the main screen. It does work.
Of course it does.
Oh, pretty neato. No need to take derivatives.
Forever
So
and ever.
if you have a computer that only does it in, I was going to say black and white, but it's more like black and green, you might not be able to see it. But then if you go to the table, you notice that the x and y values are pretty much the same until you get to about the sixth decimal place. Now, why aren't they perfectly the same?
Round years.
Yeah,
Decimals suck.
No, decimals don't suck.
because when you do the numeric derivative on your calculator, it is estimating it. Okay, it's not perfect. So, all that said, the derivative of e to the x is e to the x. The simplest derivative you will ever learn.
Watch as he makes it complicated.
So let's take the derivative of e to the x plus x squared.
Chain rule.
Indeed, the chain rule. So dy dx is going to be e to the x plus x squared times the derivative of x plus x squared, which is 1 plus 2x.
Good stuff.
Okay.
No, this is a basic lens.
Okay, now the question becomes, what if the base is not e?
You cry.
So go back to your calculator real quick. Let's make this y is equal to 3 to the x.
That looks somewhat off. I can see the red and blue mingling.
Are they the same? Well, it doesn't look like they're quite the same. Let's look at the table.
They're pretty close.
No, they're not.
Yeah, not really close enough though, are they?
No, I get further apart.
And it seems to get further apart the further you go. So they're not quite the same.
Why is that?
Well, because it's not e. So let's figure out how to find the derivative of a to the x. I've outlined the steps here. To find the derivative of a to the x, first remember that a to the x is equal to e to the natural log of a to the x. Real quick, I know that's a lot of stuff, but since e and natural log undo one another, that's just a to the x on the right. Then, using properties of logarithms, I can take this x that's an exponent on a and move it out in front of the natural log. All right. Then, take the derivative of both sides. So that would be the derivative with respect to x of a to the x is going to be e raised to the x natural log of a times the derivative with respect to x of x times natural log of a. Now remember, a is a constant. So natural log of a is also a constant. So when I take the derivative of x times natural log of a, what is that?
Natural log of a.
Exactly, natural log of a. So this is the derivative of a to the x. It's off by a factor. It's a to the x, but then you have to multiply by natural log of a. Which is why the bigger the x you get, the further it gets away, because natural log is a increasing function. By the way, is this true if a equals e?
No, it's not e to the x. A equals e.
Well, if a was equal to e, this would be the derivative with respect to x of e to the x equals e to the x times the natural log of e. And what is the natural log of e? What is the natural log of e? I'm asking you a pre-cal question or even an algebra 2 question that all of you should know instantaneously. It's 1. You've got to know some of these things, guys.
It's 1.
Yeah, without the freaking calculator, you have to know that natural log of e is 1. Maybe I should start having quizzes on this.
Oh, Lord, no. If you give us the material to study,
You should know it, but that's the problem.
Yeah, you have to know that. Just like you have to know that cosine of 0 is.
Hold on. It's 1.
Thank you. There should not be a lag in that. That needs to be a immediate thing. Okay? And what is, let's see, what other ones should you know? What's natural log of 1?
It's 0.
Okay, that one. All right. So this is true if a equals e. So if you were only going to memorize one of them, you should memorize this one. But you should really just memorize both. All right, let's look at an example problem. At what point on the graph of y equals 2 to the t minus 3 does the tangent line have a slope of 21? All right. Well, the tangent line's slope is the what?
It's the inverse of the derivative.
It's the derivative. Let's see if we can use the correct words here. So dy dt is going to be 2 to the t times the natural log of 2.
How do you write natural log so fast?
It's just
I'm writing in cursive.
He's fancy like that.
What do you do? Do you print ln?
Yeah.
I just- See, you can do it quickly.
He has like doctor handwriting.
Yeah, it looks like LY.
So 21 is equal to 2 to the t times the natural log of 2. Again, a pre-cal question. How can we solve that for t? Not yet.
Divide 21 by LN2.
Yes. So 21 over the natural log of 2 equals 2 to the t.
So that means log base 2.
Yeah, you can. I don't do that.
Yeah.
Honestly, I just don't. You can, and I understand why people do it. I just take the natural log of both sides.
You've taken the natural log of the natural log.
Indeed.
That's impressive.
And on the right side, this would be equal to t times the natural log of 2. So then you just divide both sides by the natural log of 2.
Could you do it with the logarithm?
Yeah, log base 2. So then it would be log base 2 of 21 over the natural log of 2 is t.
I think I'll like the one on the left more. I mean, the log base 2. I wrote on the left on my paper. I wrote on the left on my paper. I think I like the log base 2 more.
Yeah, the difficulty is with that is that it's harder to find log base 2 on your calculator. Natural log is on the home screen. Log base 2 is not.
You just hit the math button.
Yes, I'm aware of where it is. I'm just saying it's not on the home screen.
Hey, Irfan, you do you.
Yeah, I'm supporting the visual in a 4-year-old.
And on the AP exam, they could have either of those.
Why they gotta be difficult?
Because they hate children. Haven't you ever hated a child before? Only you.
All right, so now let's find the derivative of e to the x's inverse. Finally, inverse is the right word to use. Natural log of x. So if y is equal to the natural log of x, then using both of those as an exponent on e, we have e to the y is equal to x. And the reason that this side is just x is e to the natural log of x is just x. E and natural log are inverses of one another. So this is sort of the same way we did those inverse trig functions, sort of the same idea. So now we take the derivative of e to the y, would be the derivative with respect to x of x. So that's e to the y dy dx is equal to 1. So then solving for dy dx, we get 1 over e to the y, which is 1 over x.
How'd you do that?
How to do which?
Go from the
Here to here?
no, yeah.
You said no, yeah, so I'm waiting.
Okay. So you did.
What's e to the y equal to x? You said so.
Oh, so you just divided.
Yeah, I just divided both sides by e to the y. And e to the y is equal to x. So this is another very simple derivative. The derivative with respect to x of natural log of x is 1 over x. Now, since the derivative of a to the x is a to the x times natural log of a, it probably shouldn't be a surprise to you that the derivative with respect to x of log base a of x is 1 over x times 1 over the natural log of a. So instead of multiplying by the natural log of a, we divide by the natural log of a. I think that makes sense. All right. So a line with slope m passes through the origin and is tangent to the graph of y equals natural log of x. Find m. This is a problem that your book used it, and I was like, that was on an AP exam. I haven't quite figured out how they have gotten away with using so many questions that were on AP exams without actually going, copyright College Board, whatever, but they do it all the time.
They coincidentally make
I don't think you can
themselves.
copyright math equations.
Yes, you can.
You can?
Okay.
Math problems?
Math
Yes. So this problem, there's one almost exactly like it on an AP exam.
There's probably N on the AP exam.
Well, if they don't word it exactly, and the
Then
College
you think
Board,
you're getting close to
and the College Board doesn't bother.
Yeah,
enforcing their
I would
copyright.
say that any reasonable person who looked at it would go, okay, yeah, that's exactly the same problem. You copied it from them.
Maybe the copy, maybe
Maybe
the College Board sends them questions every week.
Maybe they made it copyleft. Copyleft.
All right, so this is y is equal to the natural log of x. And there's a line that passes through the origin and is tangent to the graph of natural log of x. There's only one that does that. It looks like this. And we're trying to find the slope of that line.
It's N.
Okay. We're trying to find the value of m.
It's not.
I bet you it's a real
Yes, since we're doing calculus and not elementary analysis where you do calculus with non-reals, that'll make your brain melt and start leaking out of your ears. So how is it that we can find the slope of a tangent line?
number. The derivative.
The derivative. All right. So we know that the slope is going to be equal to the derivative with respect to x of natural log of x evaluated at some point, but the problem is we don't know what that point is, do we? Let's go ahead and do this. We know that that's 1 over x, right? And a lot of students got stuck right there. They're like, I don't know what else to do.
You cry.
Yeah, it doesn't help. So we know this goes to the origin, which is 0, 0. And it goes through this point, whose coordinates are x, natural log of x, right?
Which is 1 over
No.
That's
Be really careful about that. The derivative of natural log of x is 1 over x. Natural log of x is not equal to 1 over x. Okay? So we could find this slope by just doing simple slope, right? So this was the key. The slope is also natural log of x minus 0 over x minus 0.
which is natural log of x.
Right. So now we have found the slope 2 different ways, and we can just set those equal to one another and solve. So the natural log of x over x is equal to 1 over x, which means that the natural log of x must be equal to 1. Where is natural log of x equal to 1?
And x equals e.
At x equals e.
I remember that.
So the slope is 1 over e.
Good stuff. Good stuff. I'm gonna look at this problem later on tonight's homework and be like, what was I doing? Please help me.
All right. And a word of caution, be careful not to confuse the power rule with exponential rules. Take this one for example. We want to find the derivative with respect to x of 2 plus sine of 3x raised to the pi power. Is that a power function or is it an exponential function?
Power function.
How do you know?
It's a constant.
What's a constant?
Power.
The power is a constant, yes. Okay? The base has the variable, the power is constant. If it's the other way around, then it's exponential.
What if they both have a variable?
That's a great question that I think we'll get to tomorrow.
You're spoiling the fun, Lance.
So basically, if you had something like y is equal to x to the x power, what do you do then?
Self-implode.
Cry.
You take the logarithm of both
Oh.
sides,
Oh, you log the. Oh.
and then you get x natural log of x, and now you can use the product rule over here. It's called logarithmic differentiation.
It's called
2 words I
I
don't
bet
like.
failed this quiz.
All right, so taking the derivative of this, what are we going to get?
Pi times
Pi times
2 plus sine 3x quantity to the
pi minus
pi minus 1.
1
It's
times
ugly.
times cosine 3x.
I don't believe in the chain rule anymore.
Times 3.
There we go.
It's more like the Russian nesting doll rule.
It very
The
much
chain
is,
rule. Like,
which I have a set of those up there.
I know they're really squeaky.
We tried opening them before.
Yes, I need to put some wax on one of those.
WD-40.
And do you know who
Those
is?
are the Russian presidents.
No, those are the Soviet leaders.
It's it's all the Soviet leaders plus the smallest one is Tsar Nicholas II, and the last one is the first president of the Russian Federation.
Who was the first president of the Federation?
Some ugly guy.
It was I'm trying to remember where.
It's not Gorbachev.
Gorbachev was the last Soviet leader.
He was the last one. I'm trying to remember what this guy's name was. I lose track.
Where did you get those?
A student of mine went to Russia, and he brought those back for me as a gift.
I know Joseph Stalin's hiding in there somewhere.
He is,
Whoa, we're fun.
complete with his little pipe. All right,
That's pretty
that is it for today's lesson.